Welcome to Get Your FRQ On. This question is from 2008. It is number 6, and it is not calculator active. In the question stem, we're given a function f equals natural log of x over x defined for all positive values of x, and we are given a formula for the derivative of f, which is 1 minus the natural log of x over x squared. In part A of this question, we are asked to find the equation of the tangent line to f at the value x equals e squared. In order to find the tangent line, we need to know what value of x we're interested in. In this case, we're interested in e squared. We need to know the y value of f at e squared, and we need to know the value of the derivative of f at e squared. We are given in the question stem that f prime is 1 minus the natural log of x over x squared. So if we plug in e squared in for x, f prime of e squared would be 1 minus the natural log of e squared over e squared squared, which is just negative 1 over e to the 4th power. We also have to evaluate our function f at e squared. F of e squared is natural log of e squared over e squared. Natural log of e squared is just 2, so we have 2 over e squared. The easiest way to get this tangent line is to just put it into point slope form. So the tangent line to f at x equals e squared would have equation y minus 2 over e squared equals negative 1 over e to the 4th times x minus e squared. Totally acceptable way to write the equation for this tangent line. Don't bother trying to put it in a different form. Every step you make trying to rewrite that in a different form is an opportunity to make a mistake. And that could cause yourself to not earn all the points possible. Once you have a correct answer and all the calculus is done, you are more than free to leave it unsimplified and not risk losing more points. Part B, we are asked to find the critical point of f, determine its type, and to justify our conclusions. So f will have a critical point wherever f prime of x is equal to 0. F prime of x is 1 minus the natural log over x squared. If we want that to equal 0, that would require the natural log of x to equal 1, which would mean that x is equal to e. Okay. For x between 0 and e, f prime of x is positive, so f of x is increasing for all x between 0 and e. And for all x greater than e, f prime of x is negative, so f of x is decreasing for all x greater than e, which means that at x equals e, since the function is increasing to the left of that and decreasing to the right of that, the function f will have a relative maximum at x equals e. In part C of the question, we are told that f has exactly one inflection point, and we are asked to determine the x-coordinate for that inflection point. The function f will have an inflection point if the second derivative of f is equal to 0 and also changes sign. Well, we have a formula for f prime. We do not have a formula for f double prime. However, we can differentiate to find one. Notice that f prime is in the form of a quotient, so we would likely use the quotient rule to differentiate this. We get x squared times negative 1 over x minus 2x times 1 minus natural log of x all over x to the 4th. You can simplify that. You don't really have to. It might be easier to solve if you do, because your numerator is a lot less cumbersome if you simplify it. If you do, you get negative 3 plus 2 natural log of x all over x cubed. And just a reminder that this is only true for positive values of x greater than 0. All right, so we have our formula for the second derivative. We want to know when it's 0. That would mean that the numerator is equal to 0. Negative 3 plus 2 natural log of x is equal to 0, which means that 2 natural log of x is equal to 3, which implies that x is e to the 3/2 power. So that would be the x-coordinate of our point of inflection. Now, for x between 0 and e to the 3/2, f double prime is negative, and when x is greater than e to the 3/2, f double prime is positive. So not only do we have the second derivative equals 0, we do have it changing sign. So we can rightly conclude that f of x has an inflection point at x equals e to the 3/2 power. In part D of the question, we are asked to determine the limit of the function f of x as x approaches 0 from the right. So the limit as x approaches 0 from the right of f of x would be the quotient of the limit as x approaches 0 from the right of natural log of x divided by limit as x approaches 0 from the right of x. However, if we simplify both of those limits, we get a limit of the form negative infinity over 0, which does not exist. Now, one thing about limits in free response questions, and this would also apply to limits where you'd have to use L'Hopital's rule, you want to be really careful using equal signs with limits if one of the limits is infinite. Because you don't want to state that the limit is equal to something. That's generally reserved for stating that the limit of an expression is a real number. So if the limit turns out not to be a real number, or if it turns out to be like an indeterminate form, you want to be really careful with the equal sign there. You'd probably want to avoid using the equal sign. And then maybe just find like a phrase that you like a little bit better. So I chose is of the form, which is sufficiently different than saying is equal to, because I'm not stating its value. It doesn't have a value. It doesn't exist. But that is something that they do look for on free response questions where you have to find a limit. You could have a linkage error. It could be poor communication, which they might notice. Could be in the scoring guide for how to handle that, how many points you can get if you make a mistake like that. As long as the limit is a real number, you're fine using an equal sign, but once the limit is not a real number, it's better to use a phrase rather than an equal sign, and try not to let that phrase be is equal to, since that is the same as an equal sign. But this one turns out to be something that's not a real number, so it does not exist.